Greetings, math fans. All right, so today what we're going to do more with vectors, and this is basically vector operations. So those of you who want to be a doctor and you want to operate on vectors, this is the lesson. I'm just kidding. Vector operations means adding, subtracting, multiplying, dividing, whatever we need to do here. We're only actually going to cover adding and subtracting, and we're going to cover something called dot product. All right, so first of all, just to remind you, math fans, that's vector notation, right? These are we'll say vector notation or brackets. Got to use those, very important. All right, so let's just start with an example. If I say vector u, it's very personal, is 2 comma 6, and vector v is equal to negative 4 comma 4, and then I say u plus v. It's really easy. You just add the x components together, so it's going to be 2 plus negative 4, 2 minus 4, comma 6 plus 4. Very simple. So that's going to be negative 2 comma 10. Okay, really easy. I can ask you for the magnitude. And of course, you're just going to say the square root of, and I'm asking for the magnitude of this guy here, is just going to be negative 2 squared plus 10 squared, which is 4 plus 100, or square root of 104, which is 1 away from 105. Very scary. And then, of course, I simplify that. I get 2 root 26. Okay? Pretty easy, right? That's just adding. Of course, you can do subtracting, whatever. That's pretty easy. All right. Let's do a couple more things here. I want to find the vector given the magnitude and direction angle. Okay, and we actually kind of did this before, but here we go. Okay, I'm going to tell you A is 5 root 2, and theta is 45 degrees. Now notice, math fans, if I'm giving you something that is 5 root 2, so we've kind of done this before. If I'm giving you 5 root 2, and especially notice a 45 degree angle, it's one of our nice little friendly angles, either 30 or 45 or 60 degree angle, you're going to give me an exact answer. All right, so that's why these answers are exact. And, okay, so if I make a quick sketch here, would you guys agree, 45 degree angle, I'm over here, 45 degrees, and A, which is 5 root 2, it's over here. All right, and, just kind of remember, right, this triangle here is x, x, and x root 2. From back in the day, right, 45 degree angle. So that means x root 2 equals 5 root 2 divided by root 2. X comes out to be 5. So that's what each of these components are. X is 5 and y is 5. So my answer to this problem is 5 comma 5. Because remember that this vector right here, math fans, I need the x and y components. And that's what I'm looking for. Okay, let's try another one here. A is equal to 4, and theta is equal to 150 degrees. Well, again, not a bad idea to sketch it. 150 is over here. The reference angle is going to be 30 degrees. This is 4. So remember, this is a 30, 60, 90 triangle, so this is x on the other side. And people born in the 60s, so this is your 60 degree angle here. People born in the 60s are radical, that gives me x root 3. And this gives me 2x. So what I do is, right, isn't 2x equal to 4? So x is 2. So this side right here is 2, and this side here is 2 root 3. Don't forget your sign. Signs are huge, math fans. This is negative 2 root 3. So my final answer to this problem, that vector is negative 2 root 3, comma 2. Okay? Last example here, I can fit it right here on the bottom. Again, my vector A, the magnitude is 105, very scary, and theta is equal to 90 degrees. Well, isn't that over here? So I really don't have a triangle. Isn't that just going to be, if my x component is going to be 0 and my y component is going to be 105? That's the answer to that problem. Okay, not too bad. All right, let's talk about unit vectors. Okay, if I want to define that, it's a vector with a magnitude of 1. That's it. It's a vector with a magnitude of 1. All right. So here's this is an example. I want you guys to find a unit vector in the same direction as 2, 4. Okay, so in order to get a unit vector, first of all, it's got to have a magnitude of 1. So what I need to do is I actually need to figure out what the magnitude of that vector is. Okay, so so let's see. First, find magnitude. And that's just going to be the square root of 2 squared plus 4 squared. So it's the square root of 20, which is 2 root 5. Okay, so that is the magnitude. And now what I need to do, so that's my first step. Second step is then divide each component by the magnitude. Okay, so I have 2 divided by 2 root 5 and 4 divided by 2 root 5. Okay, we simplify it. That's a 1, and that's a 2 and a 1. Then, of course, I rationalize it, and I get root 5 over 5, comma, 2 root 5 over 5. All right, so that's relatively easy, right? And then, again, this right here, math fans, that represents a unit vector. All right, and how do you know it's a unit vector? Well, again, it has a magnitude of 1. Well, by us dividing it by the magnitude, that original vector, that produced a unit vector. Now, it's an easy way to check it if you want to. If you have time to check it, a unit vector, remember, has a magnitude of 1. So watch this. Don't you guys agree if I square, so root 5 over 5 squared plus 2 root 5 over 5 squared. If that's a unit vector, it better equal 1. Well, let's check it out. Root 5 squared is 5 over 25 plus 2 squared is 4 times 5 is 20 over 25. So it's square root of 25 over 25, which is square root of 1, which is 1. All right, so that's what a unit vector is. It's got a magnitude of 1. All right. Let's do a couple more things here. For the vectors, find the following. 1, the direction angle. Nearest minute. And number 2, express each vector as a scalar product of a real number and a unit vector. So, math fans, the second part, basically when I divided that vector to get a unit vector, whatever I divide it by, that's going to go on the outside. Okay? So let's just kind of do this problem here first. Here's your example. Vector A is equal to 4, negative 6. Well, this is easy. Tangent of theta is equal to, and remember what I told you back in the day, don't use negative, it's y over x, right? Y over x. But always, this is always going to be a positive value. Because it's going to be a positive value because truly I'm looking for theta prime. And then I'm like, oh, okay, 4, negative 6 is actually in this quadrant here. So I know what to do with that once I get my theta prime. So let's do that. Tangent of theta prime is equal to 6 over 4. So I take the inverse tangent of that, and I get 56 degrees, 19 minutes. Okay, and that's again theta prime. And then, of course, since we're in this quadrant here, that's theta prime. What we need to do is, of course, we need to say 360. So theta is equal to 360 minus theta prime, right? That gives our value of theta. So that gives us 360 minus 56 degrees, 19 minutes. So you got theta is equal to 303 degrees, 41 minutes. Okay? That's the first part. That's the direction angle. Okay, and the second is actually pretty easy. Again, it says express each vector as a scalar product of a real number and a unit vector. So what I need to do is I need to find out the magnitude of A. Okay, and that is going to be the square root of 4 squared plus negative 6 squared. And that gives you square root of 52, which is 2 root 13. So that's the magnitude of it. Now I divide each term. I'm going to cursor down here a little bit. I'm going to divide each term by 2 root 13. So this is going to be my unit vector. It's 4 over 2 root 13, comma, negative 6 over 2 root 13. Don't you guys agree that's what we did before to find our unit vector? But it's asking you to find or express it as a scalar product of a real number and a unit vector. This is the unit vector. And our scalar is just the 2 root 13. Okay? That's because that's the number that we had to multiply, or we divided everything by. So if I want to get it back to the original problem, wouldn't I multiply everything by 2 root 13, the unit vector? Okay, so obviously the last step here, I got to rationalize it. So 2 root 13 times, you can simplify this as a 2 and a 1, and a negative 3 and a 1. And then if I rationalize, you get 2 root 13 over 13, comma, negative 3 root 13 over 13. Okay? And that's a scalar multiple. And again, that's our unit vector. Okay? Not too shabby. All right, I want to talk about one more thing here. It's called the dot product. All right, the dot product is used to determine angles between vectors. Okay, it's used to determine angles between vectors. So let's start out with vector u equals a comma b, and vector v is equal to c comma d. It's very exciting letters. Okay, the dot product is as follows. Well, first of all, the notation is this. U dot v. Now, please, oh my gosh, I can't stress this enough. I don't know how many stars I need to put around this. That's 10 stars. Okay, here's 11. I don't know how many to put around here. Okay, I can't put enough stars around that dot. That dot does not mean not multiplication. Huge, huge. Dot does not mean multiplication. It's the dot product. Okay, it's really important. Oh, I can't stress that enough. This is what the dot product is, math fans, now that I've calmed down. It's literally, using this A, B, C, and D, it's A, C, so A times C, plus B times D. All right, and basically our final answer is a real number, not a vector. Okay, it's not a vector, it's a real number. Can't stress that enough. Okay, so let us do a problem here. If I said A equals 2 comma 3, B is equal to negative 4 comma 6, and I asked you to find A dot B. Okay, the worst thing you can do is multiply together. This is bad. I'm going to show you this because I don't want you to do this. The worst thing you do is you go, oh, 2 times negative 4 comma 3 times 6. That is bad. Huge. So you're going to get negative 8 comma 18. Boo, boo, boo. Okay, that's not equal to that. Here, let's show what it does equal. Okay, it's you multiply the first terms together. So it's going to be 2 times negative 4 plus the second terms together. Okay, which are 3 times 6. So that gives you negative 8 plus 18, which is 10. Oh, how friendly. Okay, that's the dot product. The dot product is 10. Okay, very important. All right, one other thing that I want to mention here too is, and we'll talk about more about this in the next lesson here, is dot products, how to use them. Okay, basically vectors are orthogonal. You're like, orthogonal? It sounds like we're going to a dentist. Okay, no, it's not orthogonal. Okay, vectors are orthogonal, and that's just a fancy word for perpendicular. Vectors are perpendicular or orthogonal when the dot product equals 0. Okay, so that's just it's an important concept. When the dot product equals 0, then the vectors are orthogonal. Okay, so let's just try an example here. If I give you two vectors, 2 comma negative 4 and 6 comma 3. And my question is, are these vectors orthogonal? Well, let's do the dot product. Remember, the dot product is not multiplying together per se to get a vector, but multiplying the first terms together. So we're going to do 2 times 6 plus negative 4 times 3. 12 minus 12. Hey, hey. Okay, so those are definitely they're definitely perpendicular. And you know, it's kind of interesting too, because you can kind of look at this as this vector right here. It's 2, negative 4. So 1, 2, negative 4. That's this vector right here. And 6 comma 3. So there's 6 comma 3. Oh, that's kind of interesting. See that? They're perpendicular. All right, and remember, it starts at 0. Right? It always starts at 0. That's where one of these position vectors start at. And so if I look at the slope of this, don't you guys agree that this is really y, or sorry, this is x and this is your y value? And so if I do the slope, okay, the slope is going to be y over x, so it's negative 4 over 2. And then I look at the slope for the 6 comma 3, and that's going to be y over x, so that's going to be 3 over 6. And what do you know about perpendicular for slope? Isn't it opposite reciprocal? Which means change sign and flip. That's the non-mathematical word to use. All right, and so sure enough, here it is. This is equal to -2. This is equal to positive 1/2. It's opposite and reciprocal. So this is kind of another way of looking at the vector, but we're using the dot product. Okay, so just looking at slopes, I think it's kind of interesting. So let's do one more example here. If I give you guys a vector, and let's say I said 5, 3. I want it to be perpendicular or orthogonal to -7, 4. All right, and actually I'm going to put 4n. I'm going to put an n there because that's actually what we're trying to do. We're trying to figure out the value of n. So let's do it. It's going to be 5 times -7 plus 3 times 4n. That has to equal 0. It's just a very simple algebra problem. So -35 plus 12n equals 0. 12n is 35. Divide by 12. N equals 35/12. Okay, that's it. I mean, it's not really that difficult. It's just making sure that you know the dot product has to equal 0 for them to be orthogonal. Okay? Okay, so that's it for the first day of vector operations. We're going to have one more day where we do more vector operations, but hopefully you learned a little bit here. All right, adios, math fans. Goodbye.